Color temperature is a characteristic of visible light spectrum measured in Kelvin. When designing spaces, architects utilize this lighting feature to mimic natural light rhythms inside our built environment. Correlated color temperature ranges from 1000 Kelvin, which is the tone of fire, to full white spectrum between 5000 Kelvin to 7000 Kelvin, mimicking midday lighting, and ending with 10,000 Kelvin, which gives us blue rendered light tones. Correlated color temperatures are chosen carefully to motivate productivity in office and learning spaces, utilizing a full white spectrum. On the other hand, for relaxation and to improve sleep, spaces are lit with warmer color temperatures of 4000 Kelvin or lower. A growing number of experimental studies show that exposure to higher correlated color temperature ambient light, containing more blue light, can positively impact alertness and cognitive performance in children and adults. A recent study has shown that preschool-age children have achieved greater improvements in task switching performance when exposed to CCTs of 5000 Kelvin or higher. Such studies emphasize the importance and impact of light temperatures on learning experience. The combination of light and color had a great presence in the history of architecture in the form of stained glass. Colorful windows filtered light to serve an aesthetic and spiritual function in many mosques and churches throughout history. Today, the vast ranges of color-correlated temperature can be achieved using artificial lighting like LED, even in the absence of natural light. Not only humans are affected by color temperature, plants tend to prefer some rather than others. An interesting architectural precedent that embraces the aesthetic and beneficial duality of color temperature is the Netherlands Pavilion at Expo 2020 in Dubai. The pavilion was designed by V8 architects, proposing a circular climate system, blurring the line between art, architecture, and technology. The pavilion is powered by renewable energy obtained through organic translucent solar cells designed by Marian Van Obel. The solar cells filter light to certain wavelengths, creating a cool, colored, beautiful experience for visitors and a suitable color temperature meeting the plant's need for photosynthesis. Whether filtering natural light or using artificial LED, color temperature has been and continues to be a precious tool at the disposal of architects throughout ages.